Hi everyone. Today we are going to discuss about JVM architecture. So JVM architecture having mainly four phases. What are they? Loading phase, verification phase, memory allocation phase, and interpreting phase. So in the first loading phase. So in the loading phase, what will be happen? So whenever we give our class file to the JVM, so class loader subsystem will be class loader subsystem will be involved. Class loader subsystem having three classes: bootstrap class loader, extension class loader, and application class loader. So in the loading phase, these three classes will take the responsibility. So in the first, whenever we give our program to the JVM, so first application class loader will involve. It will check in our current working directory and class path setting files. So the class path setting files means if you are using other developed program, so other developed programs, whatever we set class path files, right? It will check current working directory that class file existed or not, or class path file setting directory. So it will check either current working directory or class path setting file. If it is not found, it will check in extension class loader. Extension class loader, it will also bootstrap class loader is the parent class. Extension class loader is the subclass. Application class loader is the second subclass. Whenever it is not found, application class for class loader, if it is not found, it will ask extension class loader. Extension class loader, it will check whenever we install Java software. So there in JRE, so lib folder extension, there is extension lib folder. In lib folder, there is extension folder. There, there some jars will be presented. So this extension class loader, that class is existed in this directory or not. If it is not existed, then it will ask in bootstrap class loader. So in bootstrap class loader, really, there will be rt.jar. So in the rt.jar only all java.util package classes, lang package, IO classes, everything classes, codes will be loaded from rt.jar only. Okay. It asks bootstrap class loader will check in this directory. If it is not found, we'll get what class not found error or class definition not found error. So this is loading phase. While loading the classes, the particular class is not found in these three areas. We'll get class not found error or class definition not found error. While verification, then here any location not found, then it will check given class found given class file not found in these areas. Then we will get in the verification phase we'll get that those errors actually. So these two are these phases. Next, memory allocation. So we got the class file and everything is fine. Now every class will get the memory in these four areas. What these areas also called runtime areas. So those areas are method area, heap area, Java stack area, program counter register area, and native stack area. In method area, what will be happened? All classes will be stored and all classes, all class files bytecode will be stored and all static variables will get the memory. In the heap area, what will be happen? All objects will get the memory and all non-static variables will get the memory. In Java stack area, what will be happened? All static blocks, non-static blocks, methods, non-static methods, constructors. So all static members and non-static members logic will be executed and allocate the memory for local variables and parameterized variables will allocate the memory in Java stack area. In program counter register area, what will be happen? It will have the instructions, the way of the program. So when to execute non-static method, when to execute static method, it will have that instructions. Program counter register area. What do you mean by native stack area? It will have the native methods. So native methods loads and executes actually. So for example, clone and sleep method and wait method, they developed in C language. So in native stack area, whenever we are using that logic, so in native stack area, it will loads that logic into the JVM. So it is called memory allocation. So memory allocation phase. Finally, interpreting phase. Interpreting phase having execution engine and native stack, native Java native interface. In the execution engine phase, we have three subparts again: interpreter, JIT, and security manager. Interpreter responsibility what? So everything loaded, everything done. Now our program should be executed now. So our program executed because of because by taking support of execution engine. Execution engine having three subparts actually: interpreter, JIT, and security manager. So in the interpreter what it will do? It will convert our given our given class file into current OS. Okay. So JVM is OS to OS different, right? So for Solaris OS, separate JVM will be installed. So JVM is platform dependent. Okay. JVM software is platform dependent, but our Java program is platform independent, right? So OS to OS, JVM will be different. So interpreter, it will be convert our bytecode into current OS. Then here JIT what? While executing our program, it will give more speed. Security manager, why before converting our class file into current OS, it will check that bytecode is valid or not. Then what do you mean by Java native interface? So whenever we are using our in our code actually any native methods, so so it will Java native interface will load that logic. That native logic will be loaded into the JVM. So it will ask an execution engine. I am using in my program. I am using logic, native logic. Then just it will communicate to Java native interface. It will load from Java stack area, and it will give to the our logic. Okay. So already the native logic loaded into the JVM. So particular logic to be loaded into the our class, that logic will be loaded by taking support of Java native interface. So that is about JVM architecture. Thank you.